In this video, I'm going to be showing you how you can train a custom YOLOV4 object detector very easily using QuickAI. So, let's get to it. Alright, so the first thing that you're going to want to do is install the latest version of QuickAI. So, to do that, I'm just going to go ahead and run pip install --upgrade QuickAI. And I already have it installed, so I just get a bunch of requirement already satisfied, but if you don't, it will go ahead and install that. So now, let's go ahead and create a new file here, and let's call it main.py. So in this Python file, we're going to start by importing the modules that we need. So we're going to start from QuickAI import YOLOV4 train right there. And then once we have that set, we're going to start writing the code that we need. So you can see, come to a new line, and we're going to call YOLOV4 and this class takes a few important parameters. So the first parameter is the path to the training data, and I know we don't have the training data right now, but we're going to fill this in, and then we're going to place the data and all the other files as needed. So this parameter is default set to data/object, and that's actually where we're going to keep it, so we're going to leave that where it is. Same with the testing data. The default path is test/data. Again, we're going to put our test data at that path, so we're not going to specify that. Then the data file's default path is data/object.obj.data rather. Again, we're going to put it at that default path. Same with the CFG file. The CFG file default path is cfg/YOLOV4-obj.cfg. However, our config file is not going to be called that, just to keep things organized. So I am going to actually go ahead and specify that path, and it's going to be equal to cfg/YOLOV4 So YOLO, that's set, and then the next path, the next argument, which is again optional, is the path to the starting weights. So this is the path to YOLOV4.conv.137. I will leave the link to download that down in the description.
Auto shutdown initiated.
Yeah, so I'll leave that link down in the description, and yeah. So we just have that set, and now it's time to get all those files I mentioned above into the correct location. So for this tutorial, I'm not going to be showing you how to gather data, because I'm going to be showing you on training it. If you want to gather data, there's already a lot of other videos on YouTube. I also strongly recommend using the Open Image Dataset from Google, which is actually where I got these images, and they have a lot of classes there, a lot of images, and they're pre-labeled, so you don't have to spend time doing that. But now let's go ahead and get that data. So to follow along with this tutorial, I will link the data down in the description. It'll be a zip file called data.zip, and you'll just extract that to your folder here. So I'm just going to go ahead and copy that in. And as you can see, that is done copying. So now that we have the training data, testing data, and obj.data set, and we're going to look through them now. So here you can see we just have image followed by annotation, and for this demo, just to make things a bit interesting, we're going to be visually identifying missiles from pictures. I know maybe not the most useful thing, but it's fun, and it also is good for testing, in my opinion, because most videos of missiles are high frame rate, so it shows if the algorithm can keep up with the frame rate, just what I think. And you can see, so the format of this is just images and text file. Again, I'll use the open image dataset to get this. So that's in our data/obj, which is train. Same thing here, data/test. So same structure, these are just testing files. obj.data, let's look at the structure of this file. The first thing is the number of classes. We have one class. After that is train and valid. That's the path to the txt files, and these files are not there right now. That is okay. They will be generated once we run our program. Names. This is the path to the classes of our model. So data/obj.names, which if we open that up, we just have one class. And backup, this is the path where we want to save our checkpointed weights. There's a backup folder, so we're going to go ahead and create a folder in the root of the project called backup, which is where our weights will go. So we need a folder. Here we go. Backup. So that is where our backups will go. So now that that is all set, let's go ahead and get the CFG file. So I'm going to make a new root folder here called CFG, and in that CFG folder, I'm just going to go ahead and copy in a standard YOLOV4.cfg. Let's see, here it is. In the CFG folder, I have, where is it? Okay. There. The CFG file is there now, and I'm just going to rename this to what we called in our code, YOLOV4-custom.cfg. And now we're going to take a look at the CFG file. So the parameters that you'll most likely be tinkering around with are all in the net section, which is above here. The convolutional section, everything below here is the core model. So I wouldn't recommend messing with that. But here are some important parameters we're going to go over. So batch and subdivisions are going to be your best friends if you get out-of-memory errors. If you get out-of-memory errors, just slowly decrease batch and then decrease subdivisions. Now, they have to be in powers of 2, so 2, 4, 8, 16, 32, etc. I have them set to 16 and 16 because that is the highest I can go without getting an out-of-memory error. Under that, we have the width and height. We are training a standard YOLOv4, not tiny, so that is the correct dimensions. Channels 3, we are training color images. Learning rate, just leave that there unless you want to do some serious fine-tuning. Max batches, number of batches that you want to train. I set this to 1,000. More batches, you can improve the performance of your model. Steps, based on what I found, the first value here has to be set to 80% of max batches, which is 800 in the case of 1,000. And the second one is at 90, so 900 in the case of 1,000. And that is because of this scales parameter that says when the scales have to be applied. So those are just the parameters that you'll be most likely tinkering around with in your CFG file. And yeah, I think that wraps up all we'll need. We just have to get that YOLOv4.com.137. Again, that'll be linked in the description down below, but I'm going to go ahead and copy that in. So let's get that. Get that copied in. Alright, that is now copied in. And we actually need one more file. This file is just called coco.named. It's just needed for the YOLOv4 to initialize. You can leave it blank. It's fine. Just needed for the QuickAI YOLO to start. And now we can go ahead and run this file. So, run without debugging. And our Python file has started to run. Just getting some warnings, that's fine. And you can see our training has started, which is a good sign. Now this training will take a very long time, so I am just going to cut away here once our final model is generated. Alright, so our training is now complete. We have weight files here, and now we're going to go ahead and use these weight files. So let's go ahead and create a new file, and I'm just going to close up these folders since we won't need them anymore. Create a new file, and we're going to call this use.py, like that, and hit enter. And from now we're going to do our import statement from QuickAI import YOLOV4 custom, like that. And now YOLOV4 underscore custom, we're going to call this, and this function actually has a few parameters. The first is the path to our data file. Again, it is in the standard location. We can leave that parameter to the default. Same thing with our CFG file. We have to specify that parameter again to the same as our CFG file here. So the autocomplete got that, just have to change that to custom there. Now, once we have that, we're going to set media type, which is by far the most important parameter. It sets whether we are performing this detection on videos or images. We're going to do images just for this video. Haha. And then weights is the path to our weights. So weights are going to be equal to any of these weight files. I'm going to use this one because it's the latest one. So let's get that path, backup slash that, and then our final parameter will be image, and the image will be equal to, I'm just going to call this 1.jpg, and I know 1.jpg is not there right now. I am going to get it. And yeah, so I have brought in 1.jpg. I also brought in 1.mp4, which is something we will take a look at very soon. But let's go ahead and run this, and we're going to be performing on images. And once it initializes, you can see it is loading, and it has detected the missile in our image over here. You can see the box is drawn around it, which is exactly the result we want. I'm going to go ahead and cancel that, and now we're going to change this to video. So it's very simple. We're going to change that to video, change this image to video, and not 1.jpg now, but 1.mp4. Let's go ahead and run it again, and now you see this is just a random video that I took, so I'm not going to show the video on screen because of YouTube rules. However, I will link the output down in the description. Just don't want to take any chances with that. So yeah, I'm just going to go ahead and run this, and the output will be linked in the description down below. So yeah, that is going to do it for this video. So just to recap, in this video we trained a YOLOV4 object detection model, and then we loaded that model for inference and proved that that model worked, and we did all of this using QuickAI, which is, again, a Python framework that I have made that makes, in general, machine learning very easy. So yeah, I hope you've enjoyed this video. If you did, please like, subscribe, and enable notifications, and I'll see you in the next video.